We're Team 20 doing our interim presentation on the Hoken Newtonian Reflector Telescope. So the Newtonian Reflector Telescope is a telescope designed for amateur astronomers who use this for their casual celestial observation, and we estimate production volume per year to be 50,000 units. We've identified two select groups of target customers, the first being recreational users. So these are hobbyists, amateurs who are casually stargazing. And we've also identified educational institutions to be our other target customers. So these are schools, colleges, universities who are using these devices for student learning. Here's a part list of all the parts in the Hoken telescope, and we will dive into those deeper when we go over the cost estimation. So here's an exploded view with all of those parts previously mentioned labeled. So this is an exhaustive list with all of the parts identified and fully covered.
Here we see the FAST diagram for our telescope. This diagram shows how the product will achieve its main function of magnifying objects. It'll achieve this by moving the viewpoint and resisting motion. We've created two different assembly sequences. The fishbone diagram seen here shows the assembly timeline from left to right. This first assembly attaches parts together from bottom to top. This allows the support structure to be built before the more delicate pieces are added at the end. Our second assembly sequence goes with a method that meets in the middle. It is designed to better accommodate assembly in parallel by allowing multiple parts to be built at once and then put together at the end. After comparing the two assembly sequences, we found that sequence 2 was a better method to use due to ease of fastening and joining, testing subassemblies, and assembling in parallel.
Moving on to the function component mapping matrix, we used it to visually display how each component contributes to the key functions of the telescope. One thing to note is that some of the functions have multiple components associated, like the secure position and adjust focus. And then some components also have multiple functions, like the tripod, eyepiece, and finder scope.
For the bill of materials, we lay out all of the parts. Here we see the first 10. Most of these parts are made of ABS plastic and aluminum. We used, for our rough cost estimation, we used tools such as Custom Part Net for custom parts and McMaster for standard parts. And in general, used our best engineering judgment to estimate the processes in these parts. On the next slide, we have the telescope tube and the telescope eyepiece, which we wanted to highlight as we are outsourcing those parts. And then our total cost for all of these parts is estimated to be $204, which is roughly 70% of a similar product on the market. The difference in price could be due to our outsourcing and different processes used during the process.
So the quad chart was a matrix we used to organize our primary components based on manufacturing cost and functional importance. So the foot and the cap of the tripod are designated as low importance because they're not essential to operating the telescope. And other parts like brackets and clamps, while they're cheap, are essential for the main functions of the telescope.
We then compared the functionalities of the different consumer groups. The functionalities that differ between the consumer groups were portability, adjust focus, and adjust scope. Based on these functionalities that were found to vary, the parts that differ between the groups were the mount, the eyepiece, and the tripod. For the eyepiece, a more advanced inner working allows for different optical outcomes. A scientific approach could require a more advanced eyepiece, whereas a simplistic design is optimal for commercial products. Similarly, the mounts for the scientific telescope were found to be more complex in design. The tripods are similar in design nature, but their height range and structure, as well as materials, are dependent on their use. The interface between the consumer groups we looked at was between the mount and the telescope tube. Their designs were again similar in nature, but the interfaces are more complex for a scientific-based telescope.
So for the product family assembly diagram, the variation is dependent on the primary and secondary customers. So first, the amateur astronomers might want metal legs for more durability when transporting the telescope, automated rotation, and a more advanced scope. whereas educational institutions might be on a budget, so they can only afford plastic legs, manual rotation, and a standard scope. So the parts here that are shaded in light purple represent the variation between these two customer groups, and this first assembly diagram is ordered in from the bottom up, so from the tripod towards the top of the telescope finder piece. And then for the modified product family assembly diagram, it's essentially switching the order of going from top to bottom in order to allow for delayed differentiation, but otherwise not much else can be swapped in terms of assembly order because of how the telescope needs to be assembled. That's all. Thank you so much for listening.